We have learned PERT and CPM, which give a time estimate for the completion of the project and other things. So suppose if I want to have a cost, so we have not considered the cost yet. Suppose if you consider the cost also into this picture, then how will it look? So the thing is, cost, we can always say that if it is happening normally, what is the cost? We just have to put the what are the costs for each activities and get the fact. But there are cases which can come. The total project duration I have to complete within a certain time, which means that suppose my the project duration is 20 days, but with the necessity that I have to complete the project within 18 days, then what will happen? I can complete that project within 18 days, where with the control of certain activities, if I have to put more effort in certain activities, I can reduce the time, right? So if I want to do that, what will happen? There will be a cost associated with that, because how will I reduce the total time? By allocating more resource to certain activity, or suppose I can put more men into that particular work, or I can hire more people, or I can give it to some other companies so that can be done. If you do any of these activities, it is going to increase your cost. So there has to be suppose if it is a necessary case, there is unavoidable cases could be there. Suppose if I want to establish a COVID ward, which I want to establish within a week. Rather, maybe it will take normally it will take a month, but if I want to complete within a week, that's a necessary situation that we have to work overtime, we have to use more resources, we have to use more men to work. Those kind of things will be there, where cost is not a great consideration. But for the general projects, cost is also one of the important things, not only the time. So there we have to see a trade-off between time and cost. So I have to reduce the time, still I have to I cannot give that much. I cannot spend that much money to reduce that time. Okay, so that is known as crashing. Crashing is nothing but it's a method to shorten the project duration or reducing one or more critical activities to which will be less than the normal. Means it has to be the total project has to complete with less than the normal time. So crashing is achieved by devoting more resources into the activities which is going to be crashed. So this is the philosophy. If you think logically also, you can get it very well. Means suppose if I want to do more, means reduce the time, but I will do extra work. Extra work means extra money. That's all. That's a simple logic behind it. Now, if you go more into detail, you can understand that there are two kinds of cost which will be associated with the project. One is a direct cost. One is an indirect cost. From the graph, you can understand what is the nature of this cost. Going to decrease with the project duration. So when you crash, so if you are reducing time, what will happen? The indirect cost has an inverse relationship. So if you reduce the, if you do crashing, the indirect cost is going to increase. The indirect cost and product duration means indirect cost will going to decrease. You can see from the graph, but the direct cost is going to increase. So we are interested in the total cost, right? So there can be a point which is known as the optimum point, where for which the cost will be minimum, and the time according for which that cost minimum is known as the optimum time or the optimum point where the cost on the cost curve. Okay, so so you might understand this direct cost and indirect cost. So we will learn through an example. One more thing I want to make you understand this time is the cost slope, which is known as. So we know that for crashing an activity, there will be we have to pour some money. Okay, so if an activity is completed within 5 days, for 5 days is the duration. Suppose if I want to do it in 4 days, suppose if I can do if I have to spend 1,000 rupees for 5 days, if I am reducing it to 4 days, then I may be putting more money, maybe 1,500 or 1,200 rupees, right? So so crash activity have more cost, and you can see in terms of time. So normal time is nothing but the actually, suppose we have estimated that estimated time is the normal time in the CPM. We have seen what is normal means time of this thing, right? So the normal activity, so normal time and there will be crash time means it will be less than the normal time. So that's what our intention is. And also we can see that crash cost will be higher than the normal cost. So the slope, which means that crash cost minus normal cost divided by crash time, no, normal time divided by crash time. So this minus this, which is known as cost slope. Why cost slope is important means cost slope decided which activity has to be crashed. Suppose for a project, this thing, we know that critical path, right? So for a critical path, there will be many of the activities. So if I want to reduce the amount of time, means the project duration, I have to reduce from the critical path, right? So which activity has to be means crashed? So activity with the minimum cost slope has to be crashed. Then only we will get the more output, so that we can reduce the time with minimal input of cost. So that is the criteria. So that is why we introduced the term cost slope in this thing. So let's learn it, or let's understand it with an example, so that you will understand. This is a network having activities A, B, C, D, E, F, G, and I have drawn the network. So we have given the normal cost, crash cost, the normal time, and crash time. So we will construct a network using the normal time. Now, a crashable time means nothing but the difference between the normal time and the crash time. It is just for a simple calculation. I have made it the crashable time. So it is just for a simplification. So cost slope we will calculate based on the difference between the crash time and the normal time divided by the crashable time. So that will give you the cost slope. For the activity A, so what will be the crashable time? So 2 minus 1 will be 1. For B, 3 minus 1 will be. So these are the crashable time. Now, what about the cost slope? Is this one minus this one, that will be 750 divided by 1 will give you 750. For the second activity, which is B, it is 4000 divided by 2 will give you 2000. So that's how we can calculate that. So the total normal time will be, just add all these activities. The normal time for all the activities will give you the normal cost. So sorry, the normal cost. So it will be 2,92,000. And also it was given that the overhead cost is rupees 30 per week. So if I want to work for a week, so it will means 3,300 per week. Sorry. So if I want to work for a week, it will be 300 rupees. So we have to find the total cost. Okay. Before that, we have to find the critical path and what is the duration of the project. So what are the possible paths? So one is this A, C, G. Second is A, D, F, and the third is B, E, and F. So the duration is 2 plus 2 plus 5 will be 9. 2 plus 6 plus 3 will be 11. 3 plus 4 plus 3 will be 10. So this is the project duration, and this is our critical path. A, D, F will be the critical path. Now, if I was asked to crash for 1 week, which means that I have to complete the project within 10 days. Now it will be 11 days, we know. So if it is 10, not days, let's it is all the things are given in weeks. So let it be 10 weeks. Now what will how will I do? So we know that the important activity for us is the activities and the critical activity critical path, which is known as critical activities. Because suppose if I reduce any other activity other than this in the critical path, it is not going to reduce our total project length, right? If I reduce C, so that this activity will be, means that this path will be 8, but it is not going to affect in our total project duration. So if I want to reduce the total project duration, I have to reduce from the critical path. So A, D, F are the critical activities. So A is the cost slope for A is 750, D is 300, and F is 500. So this is how where we see the comparison. So the least will be D, having cost slope of 300, which means that if I have to if I reduce D by 1 week, I can the extra amount of money I have to add will be 300. Okay, so let's first find out the total cost. Now for the present situation, so the 0th case, so first total cost will be this total normal cost plus what is the means overhead cost will be this 300 into number of weeks, which will be which we know now it is 11, which will give you 3. How much it will be? 392 33 295 300. So this much will be the total cost. Suppose if now I am doing the crashing. So I have decided means D activity is the activity which needs to be crashed. So I have enough means I can crash D activity by 4 weeks. So I will crash only by 1 week. So what is the first case? So if I crashing by 1 week, okay. Now what will be my total cost? This cost 295,300. Now plus 300 will be the extra cost, right? 300 will be added if I crash D, so 300. But in that case, we can know that my total this thing is not 11 days. It is only 10 days. So I have saved 1 week's overhead cost. So I can reduce that overhead cost by 300. It will be equal to 295,300 only, and it is the same. So I am not losing any money. Sometimes it can see that sometimes the crashing will reduce your total cost. Sometimes it can increase the total cost. Sometimes it can nullify the effect. I can also means find out by total computation like 2900 plus 300 into 10 plus the other thing will also get you the same thing. So I'm reducing by 1. That's why from this one I have reduced 300 as I'm saving 1 week. That's how I did the calculation. Now you can see that now this will be 10 weeks. Okay, this will be 10 weeks and this will be 9 weeks. So I have reduced 1 from here. So I have taken 1 from here. So still I have 3 weeks I can reduce if it is for a D activity. Now here also my this thing duration will be 5. This will be 5 here. Okay. Now suppose if I want to reduce 1 more week. Okay. Now I have to reduce 1 more week. What I will do? Now I have to see. There are 2 critical paths. ADF is 10 days and BF is 10 days. So that 2 critical paths. Now we have to see the cost slope again. So how we can do? We have to reduce at least 1 week from each. Okay. So ADF means A is 750, D is 300, and F is 500. So the least one is D with 300. So that I can reduce B, reduce D. Then from BEF, B is 2000, E is 500, and F is 500. So the possible way is to reduce F, right? Suppose if I'm reducing F, we can also see that F is a common factor in all these 2 paths, so that I can reduce only 1 activity, and I will incur this 500. But I can also do that. I can reduce D by 1 week and F by 1 week, so that this activity then what will happen is this activity will reduce to 8 weeks, because D is also getting reduced by 1 week, F is also reducing 1 week, but the total completion time of my project will be still 9 weeks, because this is going to be reduced by 1 week. So there are 2 possible ways, and among those 2 we have to take the minimum. So let's find out what are the 2 possible ways. And so I will crash D and F. Then what will be the total cost? Will be 295,300, this one, plus if I crash D by 1 week, it will be adding 300 rupees. If I'm crashing F, then it will be adding 500 rupees more, minus I can reduce, means I am saving one more week, which means I am saving 300 rupees. So which will give you 295,800. And for the second case, total, this is first case. So for one, for the second case, crash only F. Then total cost will be 295,300, which is this one, plus 500, which is I am crashing F, minus this 300, which will give me 295,500. So which is the least. So this is the least, right? So I can take this as a way, so that I will reduce F by 1 week, so that it will be 2. So this will be 9 weeks, and this will also be 9 weeks. So this is how you do the crashing. So here also F is only one is taken. Now suppose if I'm doing more crashing, I want to reduce my total time to be I want to complete the project to be at 8 weeks. 8 weeks is the time span we have. Then what we have to do, we have to see what first path means all the all the paths have 9 weeks. So I have to reduce at least one activity from all the paths. So first path, it will be A, C, G. So the minimum will be A is 750, AC is 1000, and ACG is 1500. So minimum will be A, which is 750, and ADF, D is the minimum, we know, and we can reduce this thing. And also here is a clash. So A is a common activity. So we have to see there are two ways. Either I can reduce A singly from this activity. Anyhow, A has to be reduced from this thing, and see what is the effect of this one. And also we can reduce D and see what is the effect here. And total effect we have to see. From BEF, we can see that B is 2000, E is 1000, and F is 500. So F is already saturated because we cannot reduce more from F. That is what is given here. So crashing amount it will be 2 weeks. So F cannot be crashed. So then we have only two options left with us, B and E. So B is 2000, E is 1000. So we have to crash from this 1000. So that's how we do the crashing. The more we will understand it when we do the further examples from the previous year's gate question papers. We have seen this overhead and the total nominal cost, right? But what we have discussed about is the direct cost and indirect cost, right? So the total cost is nothing but the sum of direct cost plus indirect cost, right? Now actually we have done it because this is coming, the nominal cost is coming, this is the direct cost, which is which we can find it as a sum when it is a normal time it's happening. So sum of this thing will be the direct one, and the indirect cost is given here. The overhead means indirectly it is coming. So so the total cost is nothing but the sum of direct and indirect cost. And when we do crashing, so the crashing will affect in changes in direct cost as well as indirect cost. So and also there will be cost associated with crashing, so that you have to find all these three, direct, indirect, and the crashing cost, when you calculate the total cost. So that's what one of the things that you have to remember.